Hi everybody, it's Mr. Gerhard, and we're going to talk a little bit about sine and cosecant, the reciprocal functions, and then also cosine and secant, those two reciprocal functions, so we can talk about how the graphs are and domains and ranges, all the important parts of those graphs. So the first thing we want to do is look at the sine of x and the cosecant of x. Now you have to remember that the cosecant of x is equal to 1 over the sine of x. And so that's going to be kind of very important when we get to the actual graph. But first, let's start by graphing the sine function. Sine function starts at 0, 0, goes up to 1 when x is pi over 2, down to 0 at pi, down to negative 1 at 3 pi over 2, and back up here to 0 at 2 pi. And it keeps going in both directions. And we know it's a circular function, so that we can go ahead and keep going back and forth. And so I'm just going to fill in the left side as well, so that we have 2 periods of pi. Now, the other thing that we can do, sometimes this helps to put a little bit more dots or more points into our graph so we get a better graph. Right now I'm going through the pi over 6's, the reference angle of pi over 6, which we know is either 1/2 or negative 1/2, and so that gives me some more points there that I can graph. And then I could also do pi over 3 reference angles, which is square root of 3 over 2, or negative square root of 3 over 2, which approximately is 0.8660. So I got all these nice points, and you can kind of see the graph shaping up already if you look at all these extra points that I'm putting in here, which actually makes it easier to graph. The more points you have, the easier it is to graph. And so I'm just going to go ahead and do this and finish this up here, negative 1/2 and negative 0.866. And now with the tablet here, we're going to try and graph it as best we can, but I know it's not going to be as good as it would be on paper, so we'll kind of keep going here, up and down, whoa, and up and down. It's not too bad. And so there is our sine function. Okay, let's label that sine of x. All right. So that's our first graph. Now, cosecant is the reciprocal of sine. And because it's 1 over sine, we know that if any time sine is 0, we're going to have undefined cosecant. So like right here, sine 0, it's on the x-axis. So that's an undefined situation. So we're going to put an asymptote there. We know it could be an asymptote. We know it could be a hole. In cosecant, we have some asymptotes whenever sine is 0, because it's undefined there. So I'm just drawing these in right now. One more asymptote. And then the next thing to start thinking about is, what does reciprocal mean? Well, reciprocal means flip the number. So like if I look here, my sine value is 1. Well, the reciprocal of 1 is 1. And so that points on the cosecant graph, and that points on the cosecant graph. Reciprocal of negative 1 is negative 1, and so those 2 points are also on the cosecant graph. The other really nice point that we have is this right here, pi over 6 1/2. Because what's the reciprocal of 1/2? It's 2. And so that point and that point are also on the graph, because 5 pi over 6 is 1/2, sine of that, and then the reciprocal of that is 2. And so what happens is we get this graph that looks kind of like a parabola going off the top and off the bottom of our sine graphs. Now, we don't always have to graph sine so that we can graph our cosecant, but it sometimes helps us out so we're in the right spots. We'll talk about the properties of these here in a second. So the green graph now is my cosecant function. And if I wanted to, I could get a little bit more specific. I think we said something like square root of 3 over 2 is the sine of pi over 3. So we could take that, flip it around, and I think we get 2 radical 3 over 3 as the cosecant. And so that's going to be right down here. It's like 1.15 or something like that. So there's our 2 graphs. If you want, you can look at the table on your graph and in your calculator and so on and so forth. But let's talk real quickly about domains and ranges. So if we have the sine of x, our domain for sine is all real numbers. So we go negative infinity to infinity. Our range is between -1 and 1. And we include -1 and we include 1, and that's why we use the brackets there. The period of sine is 2 pi, we know that, and the amplitude is 1. Well, cosecant is similar, but a little bit different. For example, the domain we can express as all x's such that x is not equal to wherever sine is 0, which is at 0, pi, 2 pi, 3 pi, negative 2 pi. And so it's really multiples of pi. And so we say all reals except when x is a multiple of pi. The range is also kind of tricky because we start at negative infinity and we go to -1, but then there's a big break between -1 and 1, and then we go from 1 to infinity. Sorry, that runs in there a little bit. The period for cosecant is also 2 pi, just like sine, and there really isn't an amplitude because there is no max and there is no min, so we're just going to write NA. Now, that doesn't mean we can't do vertical stretches and shrinks, but we don't classify that as amplitude. And so this helps out. This is kind of the tricky part right here where we start talking about domain, where it's all x's except when x is a multiple of pi. Let's quickly look at what the other sides here look like. Here's our graph of sine of x, and then here you can see on the calculator what cosecant of x looks like. So there's two really good pictures of that. Okay. Cosine and secant, again, are very similar. Secant of x is 1 over the cosine. So you can already know right now that if cosine is 0, we're going to have asymptotes. So let's go back here. Let's look at cosine. Cosine, we start at 0, 1, go to 0, down to -1, up to 0, up to +1. And we have a circular function again, so we can do both sides of the graph. And I'm going to go through this one a little bit quicker. You could still put in extra points, but we know this looks like a V. Oops. Trying to draw this as best I can. It's been a little while since I've used the bamboo. Sorry for the sloppiness. All right, so there's our cosine graph. And then the cosecant graph is going to be undefined, where cosine is 0, which is at -3 pi over 2, negative pi over 2, positive pi over 2, and 3 pi over 2. Now that's going to be a little bit harder to describe in a minute when we do the domain and range. Again, we have these they're almost parabolas. They're not quite parabolas. They're more U-shaped, as you can see when we look at the computer graphs on the calculator. But you can see that it goes between these asymptotes, and that'll help us when we talk about the domain and range. Okay? And again, you find those points the same way we would before. For example, cosine of pi over 3 is 1/2. The reciprocal 1/2 is 2, and so that's where that point should be on that green graph. Let's look at the computer sketches here. You can see we got cosine of x here. If I write cosine of x, we know the domain of cosine of x is all real numbers, -infinity to infinity. We know the range is -1 to 1. We know the period for cosine is 2 pi, and we know the amplitude is 1. Well, when we do the secant of x, the domain is a little tricky because it's all x's such that x is not equal to, and it's not equal to where it's at these asymptotes. And if you remember, if we flip back to the other page, it was at pi over 2, 3 pi over 2, 5 pi over 2. So sometimes we call it odd multiples of pi over 2. Technically, what we should do is we should say pi over 2 plus multiples of pi. Okay, this right here is basically saying odd multiples of pi over 2. And that's where it's undefined. pi over 2, 3 pi over 2, 5 pi over 2. It can't be 2 pi over 2 because that would be pi, and it has a value there. The range goes from negative infinity to negative 1, including negative 1, union 1 to infinity. Period is also, 2 pi, and the amplitude is, again, not necessary to talk about, although we can do stretches, shrinks, shifts, all that good stuff that we would do with any of the other functions. So I hope that helped, and good luck.